Okay, so today we're going to start, we're going to talk about taking limits as around infinity. Okay, and there's two lessons that we're going to talk about. One is answers where you get infinity, and we've looked at some of these already. And next week we're going to look at functions where you approach infinity. You go very far to the right or very far to the left. Today we're just, wrong way. Today we're just doing answers where you get infinity, or problems where you get infinity as an answer. Okay, so left and the right, sketch vertical asymptotes. We'll talk about vertical asymptotes because that's going to help you with the stuff. And then always, any limit start with plug and chug. So don't get tricked into using infinity. Whoops, I was a little quick there. And then, of course, always look both ways before crossing the street. Okay, so vertical asymptotes. What determines a vertical asymptote in a function? If I give you, first of all, you have to have a rational function. But what determines vertical asymptotes?
Denominators.
Keep going. I didn't hear the last. Go ahead, Allie. Sorry, I didn't hear the last part.
The denominators. So, like, when you get a zero, that would be the when you factor it out, and then the zeros would be the vertical asymptotes.
Perfect. Good. It's any value that makes a denominator equal to 0. So the most simple one we looked at was the mother function of 1 over x, where we have a vertical asymptote at 0. Okay. So for instance, in part A, where is the vertical asymptote? -1, right. And by the way, just to get nitpicky, because they will expect the nitpickiness on the AP test, it's a vertical line, so therefore it has the equation x equals -1. Okay. This guy?
X equals 1 and -1.
Good. 1 and -1. Whoops. Cotangent? See what you remember from trig. Guesses? If you're not sure, graph the cotangent on your calculator. Graph it in Desmos. Graph it in whatever graphing utility you're using.
Is it 0?
And?
Oh, I don't know what that second one is.
Well, not only the second one, but the third one, and the fourth one, and the fifth one, and the sixth one, etc., etc., etc. Pi and?
2 pi.
2 pi, 3 pi, 4 pi, 5 pi, -2 pi, -3 pi. Right. It is a periodic function, so you generate an infinite number of vertical asymptotes. So problems A and B, finite number of asymptotes. C, infinite number of asymptotes. Okay, so finding them is no problem. If you can find the vertical asymptote, then we can find the limits. Okay, so we take a function like this. Whoops, come on. Let's get some terminology covered. They being the College Board and the other calculus, like to use the term decreases or increases without bound. Okay, that function increases without bound. That's a fancy way of saying infinity. And so what's going to happen is we're going to get a problem like this that says, what is the limit as x approaches 2 from the positive of 3 over x minus 2? Okay. Now, from the graph, you can see that the answer is?
Infinity.
Infinity. Now, suppose you didn't have a calculator. Suppose you didn't know what that graph looks like. Now you have to figure out that answer without using these tools. And I'm going to talk you through this process. This isn't very pure mathematics, but it'll get the job done. Okay. Based on what we did in the previous slide, you should all be able to determine that there's an asymptote at x equals 2. Correct? Yes? We should also notice that this guy just happens to be where the asymptote is. As soon as those match up, you pretty much only have one of two answers. Is it positive infinity or negative infinity? And how do you figure out which one? Well, this is easy. I look at the picture and say, well, on the right-hand side, it goes up to infinity. But what if I didn't have the picture? So we cheat. We're going to plug in a number a little bit bigger than 2. Now, if I was to say that statement to my geometry kids, they would tell me 3, because 3 is bigger than 2. Calculus, that doesn't cut it. If we're going to plug in a number a little bit bigger than 2, we're going to plug in something like 2.00001, which is going to give me a positive value in the denominator. And this is an important point. Does everybody get that? Give me some type of reaction. Head shakes or thumbs up. We're good. Okay. The top is positive. The bottom is positive. Bingo. Infinity. Positive infinity. Okay. Let's do the same thing in a lovely shade of blue and come from the other direction. So same process. I realize there's an asymptote at 2. The point I'm looking for the limit at is 2. I'm coming from the left-hand side, so I'm going to put a number a little bit smaller than 2 into that function. 1.9999999. Top is positive. Bottom would be negative this time, and therefore we get negative infinity. And just for giggles, to see who's paying attention, what's this equal to?
D&E.
Winner, winner, chicken dinner. Why? Who said that? Come on, confess.
Left hand doesn't equal right hand limit.
Good. Beautiful. Okay. Infinity does not equal negative infinity. Hot diggity. Makes sense. Give me a thumbs up or a head shake. Or either way, you can shake it either way. We're good? Okay. Hopefully that's a pretty easy concept. Find the vertical asymptote, figure out if it goes up or goes down. This is all the fancy math that explains what we already talked about. It's there if you want to see it. Nobody cares. Let's go. All right. Here we go. What is the limit as x approaches? First of all, never mind. I'll just ask a question. Plus of f of x. And what is the limit as x approaches 1 from the negative of f of x? Go ahead and solve those. I'll give you a minute. Please let me know when you have some answers so I'm not just sitting here staring at all of you.
I got infinity for both.
Do we all agree with Max, or are we going to let him take us down this dark path? Infinity? Infinity for, okay, so whoever, I didn't see who talked. Infinity on the top and negative infinity on the bottom?
Yeah.
Okay, well, let's see. Max, you're up first. Can you explain why you think this one is infinity?
Because if you plug in a number that's slightly bigger than 1, you end up getting a positive number
Okay.
in the denominator.
Okay. And the numerator is already positive, so we get positive.
Yeah.
Okay. So so what did you say the other one was? What do you think this bottom one is? Also
positive infinity.
Okay, why?
Because if you plug in a number that's slightly lower than 1...
0.999999, I get a negative number.
Yeah, because it's squared, then it also becomes positive.
Very nice. Have you heard the term multiplicity before? Anybody? I assume that's yeah, some of you are shaking your head, some of you... If you have heard the term multiplicity before, raise your hand. Okay. This little guy here is what's called the multiplicity of the denominator. It determines the behavior around the asymptote. If that power is even, it will always do the same thing. Both go up or both go down. If that number is odd, one goes up, one goes down, one goes up, one goes down. So if I go back a slide, if I go back a slide, come on, 2 slides, this has a multiplicity of 1 because it's x minus 2 raised to the first power. And notice that fits in the model. One goes up, one goes down. This has a multiplicity of 2, and therefore they either both go up or both go down. Okay, this will be the fun point to argue about then. What is the following?
Wouldn't it just be infinity?
Excellent. However, there is another acceptable answer. I would accept DNE also. From a practical, realistic stance, I would probably go with infinity. However, if you were talking to a bunch of math nerds, they would want it to be DNE because infinity is not a number, it's a concept, which is ridiculous. So we're going to go with infinity. Get rid of all this mess, and then let's take a look at one more, and then we will be done. Nice 3-day weekend. Okay, how about that one? Okay, now notice, I put a minus sign in the numerator. That's going to affect the outcome. It has a multiplicity of 1. So I'm going to have an asymptote at 1, and it's either going to go up one side and down the other, or down one side and up the other. Your job is to figure out which one is which. So if you're a visual person, okay, I've got an asymptote. If I put in a number a little bit bigger than 1, I get a positive number on the bottom, so this will go this way, this will go this way, and now I can do the limit things. For these types of problems involving vertical asymptotes, I love drawing sketches. I think it's so much easier to solve the problem. Okay. And that's exactly what we thought. Okay. Now, realistically speaking, if you have the tools, use the tools. Put it in your calculator. But at that moment when you don't have a calculator, or it's on the no calculator portion of the test, if that happens, you need to be able to figure out which direction those things are when they approach the asymptote. Remember, a function can never, ever cross a vertical asymptote because it would give you an undefined term. When do I see you guys next? Wednesday? On Wednesday, we'll talk about horizontal asymptotes. And that's a different story altogether. This is what I want to deal with right now. It's just the vertical asymptotes. Is this a pretty easy concept? Okay, good. So then we should be good to go. I'm not going to take the time to do that stuff. We're just going to wrap it up. We're going to discard that. I'm going to stop my recording.